you hardly feel anything. So 80% of energy used to get spent in produce heat. It's waste, right? Heat is not the purpose of a bulb, but light is the purpose of a bulb. So how pleasant you feel under LED lamps compared to the incandescent bulbs. I remember studying under incandescent bulbs under street lights. So those days, that's the only way. And then we gradually went from there to CFLs, fluoro. CFL, what is it? If CFL stands for? Fluorescent something. Fluorescent, yeah. Halogens, and then so on. So today we have got and by the way, I think 2015 or 16, the Nobel Prize LED. Color changes. Isn't it? Yeah. For a Japanese scientist. Okay. Oh, is it? Okay. With GR, okay. So that's what underpins this is the technological growth and development and innovation driven by power saving. Otherwise, what happens is, if light bulb in the country by the typical incandescent, imagine the energy cost and energy requirement will be far higher. Again, I just put it here. It's called US baby, they call it. Minerals baby. In the typical United States, again, this is a bit dated figure. Many of the metals are not, many of the new generation metals are not part of it, but they call it every American barn will need 2.99 million pounds of minerals, metals, and fuels in their lifetime. Imagine how much salt we'll need. Do you have salt somewhere? Yeah. So many pounds, that means 26 by 2, right? Divided by 2. Have you ever imagined so much salt that we eat in our we take a pinch of it every now and then, but we never. Right? So again, in this, many of the new generation exotic minerals are not present. Like your gallium is not there, your indium is not there, your lanthanides are not there, your PGMs are not there. But if you add, it will be a much bigger number. Right? Okay. Again, coming back to the geopolitics. And look at the massive wheel. China. We talked about two things, right? Light rare earth elements, heavy rare earth elements. What are the light ones? Light rare earths. ND. keep saying what it is. But what is ND stands for? Okay, anyway, that's good. What is ND? Neodymium, yeah. ND, PR, and what are the other two? DY and TB, dysprosium and terbium. And then the rest of them are heavy rare earths. Look at India, the size of the country, we are barely scratching the surface. What does that mean? Our import check is big. You have to write a big import check. And at the same time, you are at the mercy of someone else. Not only, okay, happy to pay, but again, the pay also comes with a lot of conditions. You remember that 2010 figure, China, Japan. It is on over a territorial disengagement. And India and China always are in loggerheads when it comes to Akshay Chan, right? Akshay Chan, Arunachal Pradesh, Ladakh, Leh Ladakh. So many areas of uh, tensions. So, and look at other parts. Australia, significant. I'll show you another figure where you'll see there are about 10 elements that are required for making batteries. And if you look at the world map of the countries with the reserves in them of those 10 elements, Australia is number one. And the next, number two, is only 10% of what Australia is. That's number two. And countries, as you go further down and down, they're insignificant. But relative to inferior. Whereas China, in contrast, outnumbers every other country. We talked about PGMs, right? 57% South Africa, PGMs. So that's why India is still wanting to be part of BRICS. Russia also has a lot of. So India, at the moment, our diplomacy is working reasonably well. They're able to source materials. You look at Russia is 24% PGMs. We get PGMs. Antimony. Antimony is used. Antimony is used mainly as flame retardant in the buildings. So, if, for example, the building catches fire, there are flame retardants where antimony, like there are some fixtures which are used with that, so they use that. And then, in also preparation of bullets for military applications, and also antimony is used in the batteries. So you can look at different uh, niobium, NB. Look at that NB. Copper. So why copper? Copper is strategic, but copper is not critical because copper is widely well spread. Even India also has copper, Hindustan copper. It's not as concentrated as some of them. It is strategic metal, but it's not critical metal. Right? Any thoughts? Any?
I come from an area where project development is assigned. China give 10 license to mine. If they ever have such large quantity.
Which one? Which metal are you talking? Yeah, because silicon is required for all your solar manufacturing, everything, right? So they've got huge manufacturing base there.
They are manufacturing, but they don't have a raw material.
Yeah. See, one of the key aspects with China is you don't know whether they source it locally or they import and they show it as them. See, yesterday we were talking about rare earth as an example. China mines about 60% of rare earths. They process about 80%, and when it comes to magnets, 98%. So you don't know whether that 60% is sourced locally or somewhere else. It could be, that
20 years of that work.
yeah. Exactly.
Last years, last 100 years was done in the last 3 years. They imported it and stored it.
Stockpiling. I'll share a couple of my articles in the recent past. Because Australia wanted to put money behind stockpiling. Stockpiling used to happen. Stockpiling used to happen quite seriously in the past when Cold War era. Post Cold War era, people thought world is a open market. But now again, people have realized, resource nationalism. Better secure everything within your borders. Because when you are dependent on external sources, you are vulnerable. So that's again the key message. So China, what they do is, how can you achieve monopolies by importing and by processing everything at a dirt cheap, almost throwaway price. When you do that, you will never allow any competitor to grow. That's another tactic behind it. Like gallium that I was saying, 700,000 kilograms. Even if you look at the entire world's rare earth demand is only 230,000 tons, maybe 300,000 tons, compared to 850 million tons, both from volume and also value point of view. We talked about, right, volume and value point of view. So volume is also, in some cases, I don't know, volume is very high. Just Australia alone exports 850 million tons. The total iron ore requirement is already 3 billion tons. And the value is about $120 a ton with 65% average grade. If you dig up 1 ton, you get 65% of that as iron, Fe, highly concentrated form. And 3 gigatons, right? We said world demand today, world production. And then the entire rare earth volume is only at the max 300,000 tons. Size is small, but how much of economy they control? About 4 trillion. One is value, one is volume. Two different aspects. You were talking about Indonesia, 26%. Australia also has same, but Australia is now is hard hit because Indonesia prices. Again, a lot of Indonesian investments also comes from China, both in mining and also smelting. So again, undercut the markets. When you undercut, you will collapse. When you collapse, I thrive. And then once I thrive, I dictate terms. What price you should buy, where you should buy, in my terms. Yeah. Okay. This is again another thing. So yesterday we talked about Australia lithium production is about 51% of world's lithium concentrate. Yeah. But when it comes to lithium processing, China is up to what, 60%. And as you move further downstream, electrowinning and battery assembly and so on and so forth, so it's even more concentrated. And same with cobalt production. So cobalt, Congo is about 60%, 70% almost, right? Cobalt production. And again, processing, China. So that means criticality may not be at the mining stage, but at the processing stage for the downstream. That's another important aspect to be noted. Copper. Copper is, you can see, it's a nice mix. Hence, it's not critical. So, for example, who is this guy? Others. And this is also others. So, almost 40% held by others. And when it comes to processing, about 50% held by others, including India. So, hence it is not critical, but it is strategic. Yeah? Nickel, you look at that. Others, not as much. But what China does is they can crash the market, and which exactly they have done. I'll share tonight I'll share 3 of my recent articles that you can just read through. Okay, here is the scenario with respect to lithium value chain. So lithium value chain involves mining, refining, electrochemical production, cell production, and battery assembly. As you go along the value chain, you will see too much market concentration here in these two areas. Here at least there is a bit of diversification, and Australia is majority in terms of mining. But criticality is here. But again, there's a bit of relaxation here. Other countries are also playing their part, like Japan and Korea, which are not as aggressive as China when it comes to controlling the markets. Yeah. So now India is trying to get here and also here. So there are many players like Amar Raja Group in Hyderabad itself, and then Loham also in Hyderabad, and then you got which is that in Tamil Nadu. I'd been to their factory. It's a big one. It's a completely Kodai Kuri or something in Tamil Nadu. The beauty of that place is 100% women operated shop floor. 100%. I was so impressed, including all the assemblies, everything. Women, 100%. No male. Male are forbidden, which is amazing. What is that place? Which is that company? No, Koraikudi. But that company name I'm looking at is that Agarwal's. Oh, they are into now two-wheeler and three-wheeler. Huh? Ola. Yes, Ola. That's right. Yeah, Ola. And then a few others are coming up. Gigafactories are coming up. Yeah. So again, it's important that you have a bit of diversification in the cell production and assembly. But whereas in the first two places, you got too much market. China 75%, China 90% there. Okay, here I think minerals mined in 1950s and minerals that are strategic in 2012. Just to give you some examples. So I think we said cerium, praseodymium, neodymium. Oh, there's lanthanum missing there, right? Okay. I think until here they are light rares. Here they are all heavy rares. Which are the two other metals that we added to rare earth family? No, these two, scandium and yttrium. Scandium and yttrium. All right. So this is kind of India's installed generation capacity, which was 421 megawatt hour, fossil and non-fossil fuel. I think this has already crossed. This is slightly dated numbers. Fourth in wind power capacity, including large hydro and solar power capacity. Per capita electricity consumption doubled from 631 units to 1255 units of oil equivalents, which is 1.3 megawatt hour per person per year. So this is kind of India's 2000, I think it was 2022 scenario, but it's improving. It's changing very fast. So I think we touched upon some of that, but these are the that are very, very crucial for energy transition story. So praseodymium, neodymium, terbium, and dysprosium, that's platinum. Chromium. Where do you think chromium is used? Alloys, yeah. Chromium coatings are used to kind of prevent corrosion. So 140,000 tons of rare earth oxides. China produced one third. You remember why there was a coup in Myanmar in geopolitics angle? You remember there was a coup, military coup in Myanmar. Aung San Suu Kyi, she was dethroned, right? Back in which year? 2018? No, or some 18, I think. Yeah, around 2018. Like, one of the key reasons is this: had it been a democratically elected government, that would be available for Western markets. But if it is a dictator, who controls it? China. And a lot of Chinese firms. And in fact, there were many reports that came in environmental point of view. So what happens is when someone else does mining in your backyard, they want to get out as quickly as possible. So they do all filthy job. And who has to feel the brunt? People. Because they will leave. They will make profits and they'll leave. That's exactly had been the China's strategy in every mining.
Then, so Myanmar is right there.
How is it?
They have this thing that
Yeah, it is.
yeah, yeah, going because they're worried and trapped.
Because, see, it's all military dictators, right? And they are funded, they are corrupt, they are.
Then why can't they not stepping out?
Yeah, you're right. Again, that's a geopolitics. Why is a big question. For that matter, Pakistan also is our next door neighbor. It's another state of India. Why not India? Why someone else?
And even Bangladesh also.
Bangladesh.
And India is a major role in formation of Bangladesh.
Mm.
But right now,
Yeah, they have constructed this Alabama. What they have constructed with because it's a nearby countries and it's more yeah, maybe there should be some strategic decisions.
Yeah, well, see that kind of strong position you will only get provided your defense is strong, and that's what the government's current focus had been. See, remember there was a time when we used to depend on external sources for every pin to plane in defense. Today, at least, we are net exporter of defense manufactured things.
so frankly, India is having only one big power, that is military.
Country.
Remaining other things we are.
But that's most important power to have.
Now,
What US also is the same, right?
now, right now, why these sanctions are exactly hit by the India during the Operation Sindoor. That is only US only. That's why
Thanks, sir.
sanctions.
Same like
Exactly. So, other countries who are eyeing on the same region will always try to keep those problems alive. And only you will be able to address the problems provided you are strong enough and your people are with you all the time, irrespective of whether your decision is wrong or right. People are impatient, right? We don't want any inconvenience. We want every right. I was telling yesterday the example of, if I don't get my oil supply and if oil prices go up by 2 rupees,
We are
I'm not saying you should not do it. You should do it. And governments have obligation to do.
in a highly inflation world.
Mm.
Till today, that's why the three major things are the sources for Indian government. One is oil, and another one is electricity. Third one is the drink related. But still,
But to scale up, we need
as Mr. said, 80% dependency. But unfortunately, it was enhanced to 89%.
Mm. No, because consumption is going up. No?
Yeah.
Consumption steadily goes up, whereas supply is the same.
If we can calculate the cost related there, how much.
Don't you think politicians that like keeping the close neighbors close to for your own interest? I mean, okay, Western countries are there, but I mean, if you can't put a strong position in the whole neighboring countries.
I know what you're saying. I perfectly agree. See, I'm trying to be as close as with you as possible. From my end, I'm making every effort. But if you have, bloody Mohan is hypocrite, Mohan is a dictator, I don't want to work with him. How can I change you?
Earlier, for this purpose, only sought this form. But unfortunately, of course, India is a peaceful country, but surrounded with
I mean,
a lot of.
African connections are all fine, but why not also our neighboring countries? Look at them first.
Look what happened in Sri Lanka.
Yeah.
We were very friendly. We gave them everything.
Even Bangladesh, what have we not given them? Literally, we built 3 electric power plants, ports.
No, instead of adding in 26th state, we are just even independent at the time.
See, it is their problem. It's not our problem. Our approach, our intention had been steadfast. That neighborhood is first. Pakistan, we did everything to them. They are not ready to work with us. What we can do? And there are motives for that. These countries are bankrupt. A lot of corrupt practices.
Even 11 years before, they have the American states, right?
Yeah.
Wherever.
So their politics are very corrupt. Their military dictators are the ones who rule the countries.
But if you want to how critical airline happen. So, I mean, India, countries, India has to give this country better, right?
And good thing is, yes, I got your point. Except Myanmar, none of the other countries have got any notable deposits. And the exercise that we do this afternoon, the tutorial, we'll try to understand, Mm. Yeah. So again, there has to be short-term strategy, medium-term strategy, and long-term strategy. So in the short to medium term, source where they are easily available. In long term, you develop your capabilities. See, still we are 4 trillion economy. We need more money, more investments to come in.
What is about adding today?
True, yeah. So although we say it is 4 trillion, so maybe I would say I would give it 8 trillion. Because with many things that you cannot buy even with $50 in the US, you can buy with 5 rupees here. So you cannot go on that simple one single metric of the dollar.
Only that relations will continue until you provide the value addition. So, particularly when you are look at the small countries. So once you stop or reduce your contribution, definitely they liable to switch over to whom.
Exactly. So everyone is chasing the same So Indo-Pacific is highly contested region now today. One, excess population, people are very, very ambitious, and when to match that ambition, you don't have enough economic opportunities. So then, and corrupt practices in those countries. So you you just work with a couple of military dictators, and they will switch the way that they want.
Yesterday also is Pakistan. These people become spokespersons, right?
Yeah.
Battery energy storage system. I don't think we derive
Exactly. That's why if you look at, I really appreciate Minister Nitin Gadkari. Every time he goes on record, he says hydrogen and what you call this ethanol.
It is focused on green hydrogen for the logistics, so that actually the logistic cost expenditure to reduce. And of course, E20, right now we are talking about advantage is difficult because E20 mileage right now reduced to 9 kilometers per liter, from 15 to fall down to 9 kilometers. I don't know still exactly. And also it requires water to produce when you are producing ethanol. So right now, compared to sugar production, that focus on the ethanol production.
The problems are there, but there are also at least attempts to overcome them. That's what I see as very positive, aspect as far as India is concerned. Yeah, so that's a kind of mix used. Oops, sorry. Yeah. 29, 20, blah, blah, blah. These are India's import reliance for critical minerals as of 2020. And I think it hasn't changed. Look at that, 100%. And most countries are reasonably okay to predict, except China also, we are working, we are all right. We are not that, we are not, when you have two neighbors, you have some issues, right? Always. Even just imagine your own household and you got a neighbor. Sometimes some neighbors are good neighbors, some neighbors are really pain, right? And this is again another important. How is the future demand going to look like? Say, if you look at lithium, cobalt, nickel, copper, and rare earth elements by 2040, the energy, clean energy, the green energy transition itself is going to consume nearly 50%, constitute 50% of rare earth demand. And the current 300,000 tons is not going to remain 300,000 tons. When everyone is transitioning to cleaner and greener energy, that is going to exponentially grow the demand. Right? Any thoughts? Any questions so far? All good? Yeah. So then, major criticality studies. How much time we left? Half an hour. Half an hour. Yeah. Okay, we'll complete some. So this is where again some of the important studies as far as major criticality related studies. If you look at National um, Research Council, the first study that came to life was in 2008 by, it was commissioned by US government, and it's NRC study. And then Oakdean Holiness study, so developed the criticality matrix, including two dimensions: the impact of restrictions and supply risk. That was in 2008 for US. They did it. Then VW study developed different things. Again, this is from one of our papers that we published in 2015. So you can see GE, because that's also a big manufacturing beast. So they also have done their own critical minerals risk assessment, and then European Union. In fact, I was also involved partly in I think it was 2012. I was called into a workshop where it's 2012. Right? Department of Energy assessing the criticality of minerals used in the clean energy sector. That was in 2010. So if you look at the critical minerals assessment, this is National Research Council, minerals, critical minerals, and US economy. The first report was published in 2008. So mineral is often defined loosely. A mineral is critical if high risk of supply disruption and impact of such disruption is high. So there are two-dimensional matrix that they developed. So that's supply risk is low, supply risk is moderate, supply is moderate and high. So that's how 1 to 4 scale. And then you have got y-axis, you got impact of supply restriction. So that two-dimensional kind of matrix that they developed, where a few minerals have been kind of put here. So copper is, the impact would be high, but the supply risk is low. So where you will be focusing is the supply risk is high and also the impact is high. That is where the focus. And then you strategize how do we de-risk some of that.
It might also depend on the market conditions, right? Like cheap and economic. And if there is no market, why someone can afford it, right? If there is, how can I, why companies should be there from different companies? Or there might be one sense of demand and supply condition. Just to
Yeah, I got your point. So it's again, when it comes to critical minerals, there's government as a key stakeholder, and there's also business. So that's why, if you, in the previous slides, we looked at some of the studies by GE, and other companies also have undertaken their own risk assessment of critical minerals supply chains, right? So they know for sure, what kind of quantities that they're going to need in next 5 years, 10 years. So accordingly, they bet their odds. And same with the governments. Governments know. Again, stockpiling was quite imminent before Cold War, during Cold War. And so soon after Cold War, people thought the world is a fairer place. And then everyone, because if you have to stockpile, you have to spend money. So then people thought, okay, oh, that's a free market. She's ready to sell, and I'm ready to buy. So everyone thought, oh, she's fairer, I'm also fair. So no stockpiling. We discontinued, but it's not. But now people are thinking stockpiling, even including India. So people are like a country like India is now working in partnership with Australia, where you got security of supply. So they will not threaten like other countries, and you got no border issues with Australia, right? It's rule of law, we call it. So this is one of the approaches. And the second approach is Yale methodology, which again came around 2008. And then many variants on Yale methodology have been applied. So this is again, compared to the NRC, it's two-dimensional, which is supply risk and impact of supply disruption. Only two axis metrics that they came up with. And again, note that they are all static approaches. Like, at any given time, if you want to look at, they can assess, which mineral is going to be critical, but they are not dynamic in nature. So this is again three-dimensional, where you got supply risk, vulnerability to supply restrictions, these as it is in the previous one, but they added another environmental implication, third dimension, right? So what you have is here human health, ecosystem, cradle to gate, recycle inventory, environmental implications, then companion metal fraction, depletion time, geological, technological, and economic, that's supply risk. And then you got also vulnerability, supply, importance, and substitutability. So this is a three-dimensional matrix where they came. And see, a metal, so according to that, you can have a metal A, metal B, and metal C. So then people could make, again, this is also a very static approach. It uses multi-criteria decision analysis based approach. Then, because a lot of that judgment, what kind of weights should be given to each of them. Generally, what they do is they give equal weights. And again, that's based on some human judgment, expert judgment. So there's still a human factor. There's still that subjective behavioral aspect, right? Then when I came out of Yale after my sabbatical back in 2014, I said, okay, this still has some flaw. That is, it is still not objective. It's still, that human input is needed. Can we do something else? Then I recruited a PhD student who worked on agent-based dynamic model, which just by observing the trends, he has used AI/ML back in 2015. He started and he finished his PhD in 2019. So we came up with agents statistical learning, and that's more dynamic. So it would look at the trends and then it would give you, which is dynamic in nature, which is not static. And there's no human judgmental aspect, it's more objective, right? So what are the typical 10 desirable attributes of criticality? It has to be broad, it has to consider all factors, address substitutability, addresses the issues of companion metals, considers recycling, addresses different entities, and so on. So there are 10 commandments of what a typical criticality model should look like. Right? So this is our model. This is a study by my PhD student. So there are a couple of papers that I've given if you want to have further look at it. But anyway, I will send some of them. So what you have is you've got the kernel, and then you have got the constraints, and then you got constraints. So what you have is our proposed criticality system include the outer layer containing the constraints and market variables. It's all market driven, right? Then the kernel representing agent interactions. So there are three types of agents. One is regulators, which is government, and then mineral consumers, which are companies, like for example, Amara Raja Group, and there are mineral suppliers, like let's say NMDC, for argument's sake, as a company which produces minerals, or Tata Steel, for example. Tata Steel is a consumer, also producer. Hindalco, consumer as well as producer, right? So there are always that interactions happening. And there are market variables like production, consumption, price, reserves, and consumption structures, and then supply concentration. So these are some of the supply risks. These are some of the vulnerabilities, and then all of that. And then the feedback loops. So we developed a system dynamic model, which is agent-based, and that gave more dynamic prediction of criticality. And anyway, I'm not going to go into the details of what exactly. So again, you can look at, I think this was a case for platinum, illustrates the outer layer and the kernel of the criticality system of platinum, and how constraints and the market variables of criticality systems are analyzed for trends using statistical learning, AI, ML based learning. So you got, yeah,
Something data.
exactly,
Maybe how the previous list.
exactly. But again, the problem is we don't have much data with the critical minerals. Right? No, but you only have to you only have to give the data, and then it will do auto correlations and everything else. They're completely automatically driven. The human intervention is not there. That agents are nothing. So the agents are nothing but these. These are the agents. 1, 2, 3 agents. Right? The agents are not people. Agents are the stakeholders.
Usually it goes based on the data. In the 100 data point, it is the one of the data point based on the 100 data stats. So we can't predict the meteorological data status or if it takes something in the previous data. Instead, actually, it's focused on the
I think people are doing reasonably good predictions. So there are a variety of ways in which you could use your proxies to train your training data set and prediction data sets, right? And then you do reconciliation over a period of time. And people are able to achieve reasonably good confidence levels. Yeah. Yeah, mainly criticality. Yeah. So again, this is a bit more complex. You got market variables, you got constraints, and then one is outer layer, one is the kernel, and then you got criticality system of platinum. And then here it illustrates how the constraints variable correlations, mutual variable correlations, and so on and so forth. So this is how the model was built. Again, the ultimate aim is to tell you which mineral is going to be critical for which sovereign entity point of view. And 2 more papers are under review currently. So again, you can just do some typical comparison between Department of Energy study, NRC study, and IDA study. You know, what are the geography, time frame, minerals candidates, how many number of critical minerals out of them, methodology, and you can go on and on, you know, comparing the various studies that we have looked at in the previous couple of slides. I can supply you these slides if you want as well. So again, just these are the EL studies, these are the agent-based studies. You know, agent-based studies, until we kind of took it, it wasn't popular, but now a lot of people are kind of using agent-based stuff. And again, many companies which do their internal risk assessment, they don't reveal what method they use. We assume that, you know, dynamic criticality methods are more popular. So that's the Indian critical minerals list. India has finally published, you know, after several years of my persuasion with the government. I started, as I told, my first email to secretary, the then secretary was in 2014-ish. So finally, by 2023, the first critical mineral list was published, and now National Critical Minerals Mission has been announced. I think just around this time of our symposium, right? Yeah, just after that symposium. So these are about how many? 1, 2, 3, 4, 5, 5 times about 30. Yeah, about 30. So most countries have about 30 of them as critical minerals. So this afternoon exercise, we will look at exactly this and then see what is India's position. We'll do some exploration, searching websites, and then. Yeah. So here is again risk lists of critical metals and minerals by different countries. So Australia, that's 2020. But again, noting that Australia's criticality is not for self-consumption, but for the consumption of its allies and partners. Yeah. Yeah. And US, Canada, you can look up, you can go on various metals. Again, there's a color coded thing, so that we'll come to it. But just keep in mind this color, this color, this color, this color. What does it mean? So the list goes on. I think that's so element critical in greater than 5 countries, elements critical in 3 to 5 countries, most critical, moderately critical, least critical. So see, in everything, understanding the problem is the key, right? Then you can come up with strategies to de-risk them. So I think finally you are able to capture the essence of it, and then accordingly you will do all that bilateral, multilateral, uh, friendships or partnerships to overcome the issue. While at the same time you are trying to do your own domestic exercise to increase your stocks and flows. Where was India in this? Oops. So India is here, last 2 columns. Again, likewise, this is again a Canadian study, and then Japan has done their own study, Korea has done their own study, and so on. I think I will stop there. So, what time we have left? About 8 minutes. So, any questions or any comments or any further discussion? What do you think? Anyone else who wants to have a say as to what takeaway message is for you as an individual, and what you could do to alleviate the issue at home? Any further thoughts? Take the mic so that everyone can hear clear.
One is to prioritize main goal. If you want to invest, you need to focus on one category, focus on everything else. Yeah. So only the sectors. So we can focus these are sectors, and then based on that, maybe get sort of what you need to focus.
Yeah, good point. Yeah. Anyone else who wants to say something?
Like, I'm a research scholar. So, understanding of today's lecture, I think to know the importance of certain methods in certain areas. So, when we started working on these critical methods, I came to know very few information related things available online. But from the students, like they're reading so many books at a time, and that is a very good thing. So, by understanding and understanding the need and importance, making thorough research, um, like research, doing research is something different from doing it the right place. So as in India, it's not, we don't have much awareness on this critical matter. So any opportunities
research scholars to get in touch with the right places for conducting more research on these areas.
Absolutely. So now there's a minerals security partnership. Sorry, MSP is that US led, but Australia and India also has bilateral partnerships now. So there's called Minerals Scholars Network. Minerals Scholar Network. So CSIRO is giving a lot of fellowships. No, that's different. I'll come to that also. So this is federal government money. They gave nearly $14 million between Australia and India to support critical minerals research, both in processing, extraction, everything else. And then besides that, Australia Indian Institute. By the way, tomorrow, no, on 14th, we have a program. I'll share the link again tonight. I'm coordinating an online workshop. Again, the purpose is advanced manufacturing. The theme is, we are looking at 3 themes. Let me see. Oh, it's on my computer, right? Can I plug my computer there? I can quickly show. Oh, it's HDMI, right? Oh, yeah, easy. Oh, we are meeting in the afternoon, right? I'll show you then. That's okay. Now let it be. So we are hosting this Australia India Institute sponsored program where we are asking people to come and join and then discuss how do we go about. And then the recommendations from that online workshop will be submitted to both the governments as to do more things. What you are doing is good where you have started. There's something for everything. There's always a starting point, right? But that's not the point. That's enough. We need to do more. The problem at hand is big, and the effort is small. So we need to increase our efforts. That's one thing. Both from policy point of view, technology point of view. Like again, coming back to your question as to what you should do. Last time when I came to IIT Hyderabad, I was asked to give a lecture to chemical engineering. No, civil, I think. I gave a lecture. Were you there in the lecture? In the yeah. So my title, no, that was one before. When I came for the symposium, I gave a lecture. So the title of my talk was "Think Global, Act Local." What is in it for you and me? Like when you think the global issue, critical minerals is a global issue, but you have to act locally, right? What is in the interest of India as a country? And there's everyone's role, your role, my role, and in institutions' role. And I keep saying this to a lot of youngsters when I meet. What percentage we, what do you think, how privileged are we when we compare to 1.4 billion people in the country? We are in the top 5%, right? At least, if not top 1%, who can come to IITs, sit in an air-conditioned, well-lit room, eat good food, very hygienic conditions, very quiet environment. We are the top 5% in the country, right? Is that right assumption? How many people qualify to get into IITs? Very few people. So if you and I cannot think good of this country, who will think? That's what I said, I think, right? So we have to think. Again, there's a book called 7 Habits of Highly Effective People. It's written by Shiv Khera, a good book that you should all look at. One of the key habits that he says is begin with end in mind. Begin with end in mind. So if you are just, again, going from think globally, act locally, begin with end in mind. What do you want to achieve at the end? Okay, doing your PhD is good, but what after PhD? What kind of technology that you are developing in the lab that you want to commercialize? So if you start thinking, everyone start thinking, think globally, act locally. Right? So just don't be confined. Okay, doing research for research sake is one, but research for commercial sake is the ideal setting. And in fact, two of my PhDs have started their own startups, and one survived 5 years. They call that first 5 years is death valley. Generally, most startups extinct, but he survived. I think he's coming one of our lectures, Shashi Bhushan. Very enterprising. He got IIT positions and NIT position, but he said, no, let me start my own thing. And what he did, the technology that he developed in the lab, he wants to kind of commercialize. With that intent, he started. And now there's an ecosystem like that. The government also facilitate that kind of risk-taking approach. So in my time, either job or jobless. You cannot have too many experiments in life. In fact, I used to play good cricket those days. My father used to scold me every time, do you want to become Patodia or Gavaskar? Had I pursued my interest, probably you never know. But the chance was 1 in, what was it, 12 people only make up the team. And at the time, the population of the country was maybe 60 crore. So very tiny, right? Either you become that or you become jobless. Now at least IPL and all this. I used to play very good cricket. I used to play for Usmania University. Really good batsman. But what you can do? But what is the most secure way is, okay, you pursue education so that at least you'll get a job, right? But now at least compared to those days, you have far more better conditions in the country. Hope I could touch upon some of your doubt, right? Any other? People used to find it hard to get me out. Yesterday, I bumped into a childhood friend in my hometown and said, man, you used to be a nightmare for the bowlers. I became from Rahul Dravid to Dhoni, those days. Then I continued a little bit of my cricket after I went to Australia also. They used to call me Dhoni sir, Dhoni sir. Okay, we'll start. Thank you. So we'll meet in the afternoon to go through some. We'll have to get some of the printouts.